Okay, so in the last video, we're going to go over our exponential stuff. So remember, these are things like population that are growing up exponentially or decreasing exponentially, or diseases that take off with a few sick people and all of a sudden they skyrocket up to lots of epidemics, or they get the drugs and then they start coming down and they'll level out. So the A is the initial amount, how many people were sick at the beginning or what your population was at the beginning. And then B is the growth or decay factor. If it's bigger than 1, it is growing or going up. If it's less than 1, like 0.9 or 0.2 or 1/2 or 1/4, it's coming down. And X is your time period. Might be weeks, might be hours, might be months, whatever they tell you it is. And then Y is your total at any given time. So there's your little formula. So over here on these first ones. Oh, by the way, we're doing 1, 2, 3, 4, and 5, and 7. We are skipping 6 and 8, so don't do 6 and 8. So they ask us to find the initial amount and the growth or decay factor. So the initial amount is the 129. The thing that has the X with it, that is your number. That's the growth or decay factor. If it's bigger than 1, it's growing. If it's less than 1, it's decaying. So, of course, the initial amount is 129 somethings, whatever this situation may be. It is growing because it's bigger than 1, and the actual growth factor is 1.63. So on the second one, here it is again. It's exponential because the X is the exponent itself. So that's how you know it's an exponential equation. 2 is what we started with, the initial amount, and then 0.65 is smaller than 1, so the growth or decay factor is the number with the X as the exponent. So 0.65 is decaying, and that is the decay factor. So pause the video and go do 3 and 4 and see how you do. Hopefully you pause the video, and now you're going to go check your answers. So the initial amount was 12, and 17/10 was your factor. The question is, was it bigger than 1 or less than 1? You can go put 17/10 in the graphing calculator under the add subtract screen and hit Control Enter, and it will change it to a decimal, in which case it was 1.7. And of course 1.7 is bigger than 1, so it is growing. The other way you can do it is if it's a fraction, look at the top number. Is it bigger than the bottom number? If the top number is bigger than the bottom number, then it is growing. If the top number is smaller than the bottom number, then it is less than 1. Okay, so there's that. This one, the initial amount was 0.8. Maybe you had 0.8 pounds of radioactive material. It is decaying because 1/8 is less than 1, and 1/8 is the decay factor. Okay, next section, they want you to graph these. So all we got to do is go put this in the graphing calculator. So when you type it in, you have 6, the y equals is already there, 6 parentheses, 2, close parentheses, rooftop x. Remember the rooftop key is right below the equal sign. You want to raise it to the x power. Now we can answer some of this right off the bat. The initial amount was the 6. The growth or decay factor, it is growing by 2. And the y-intercept is 6. It's the same number. Your initial amount and 6 are the y-intercepts. So when you go sketch it, now you already know the y-intercept is at 6, so you could go over here and count off 1, 2, 3, 4, 5, 6, put a dot there. The picture looked like that, so just make a little rough sketch. It doesn't have to be pretty. Then you can see that it's flattening out here at the x-axis, so this is your horizontal asymptote, which is y equals 0. That is the equation of that horizontal line. All horizontal lines start with y equals a number, and it is crossing the y-axis at 0. So my horizontal asymptote is y equals 0. You can go do Control T and make the little table. And so if you look at the calculator screen and do Control T, you can see the x numbers and y numbers and fill them in. Now notice this thing was doubling, right? That's what the growth factor of 2 means, you're doubling. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So the pattern is times 2 times 2 times 2. So that's what where that number comes from. You're multiplying by 2. And of course this is a geometric sequence, and geometric sequences are the same thing as exponentials. All right, the other thing they asked for here was the domain and range. Does it have arrows going left? So I'm going to go left forever. Is it going to go right forever? Yes. Will it go both directions? Yes, all real numbers. However, the y's, they will go up forever, but will they ever go below the x-axis? No. So they're all bigger than 0. The question is, are they equal to it? Is it ever going to touch the x-axis? No, so it will never equal 0. It's all numbers bigger than 0. Okay, so now we're going to do the next one. So give us a whirl, put it in the calculator, pause the video, and go try number 7 on your own. You can see the y-intercept. You can see the growth or decay factor. This one's less than 1, so it is decaying. So hopefully you said, okay, if the initial amount was 3 somethings, it is decaying. 0.5 is the decay factor. The y-intercept is 3, so when you graphed it, you went over here and did 1, 2, 3, put a dot there. You typed it in the calculator, looked at the picture, made a little sketch. It was flattening out right here on the x-axis, so the horizontal asymptote is y equals 0. That's the equation of that line. So y equals 0 is your horizontal asymptote. You can do Control T in the calculator and then fill in the table. Notice it went from 12 to 6 to 3. Are we multiplying times 1/2? Yes, because 0.5 is the same as 1/2. So times 1/2 or times 0.5 over and over and over to get the next number. Half of 12 is 6, half of 6 is 3, half of 3 is 1.5, and so on. So that number is what your pattern is in the sequence. Of course, we talked about the range is everything bigger than 0, and the domain is all real numbers that goes left and right. Okay, that is it, guys. Do well on the practice STAR test tomorrow. It's just to let us see where you are, but do the best you can, because it's always important to let you know what you know and what you don't know. Most of you will probably either pass it without doing the review, or you will be really close to passing. And this is before we even do the review. So after the review, your grades will only go up higher when you take the real one, and hopefully most of you will be up and making like A's and B's on it. So anyway, do well tomorrow. Get a good night's sleep, and I'll see you the next day.